In this third video, we're going to move on to solving problems in 3 dimensions. Now, the trick here is to try and visualize what is happening when you're looking at a 3-dimensional figure. If you have a look at that shape over there, okay, here you have your vertical lighthouse. Okay, you are told in this particular case that you have the Slankhop lighthouse. A, B, and C are points in the same horizontal plane. So point A is the bottom of your lighthouse. D is going to be the top of your lighthouse. All right. Points B and C are in the same horizontal plane. Now, the angle of elevation of D from B, all right? So, if, for example, this point over here is point B, when you look at this, when you stand at B and you look at the lighthouse, you are looking along that line over there. The angle through which you look up is the angle from the horizontal up to that line that joins point B and point D. Now, we somehow have to find a way of drawing this in 2 dimensions. So what I have done, if you can visualize, I have done that. Can you see the diagram? Here is DA, all right, the height of my lighthouse. I have called this point over here B and this point over here C, and I flattened it to get that diagram over there. So when we start filling in information, it's really important to realize that when you talk about height, these angles here are both 90 degrees. All right. Now we are told the angle of elevation of D from B. That's that angle over there, and it is 35 degrees. We are given that BC is equal to 96, that angle ACB is 64, and that angle BAC is equal to 110. And the question is, what is DA? So again, we have to plan how we're going to tackle the sum. My target is DA. What triangle am I going to work in to find DA? Well, DA belongs to 2 triangles, that one over there and this one over here, but I'm clearly going to pick DAB because I know more about that triangle. I know that that angle is 35 degrees. Having established that I want to work in this triangle here, what do I have to find? Well, I need a side, and the only side it's possible to find is the length of BA. And to find BA, I'm going to work in triangle BAC. So when we tackle this problem, we're going to start off by working in triangle BAC. If I look at this triangle, I've got this pair, a side and its opposite angle. I know that I can use the sine rule. I want to find BA, so I'm saying BA over sine of the opposite angle. It's going to equal 96 over sine of, let me cross that out, sine of 110. In other words, BA is equal to 96 multiplied by sine of 64 all over sine of 110. When I work that out, it is 96 sine of 64 all over sine of 110. And my answer is 91,82. I've now found this length over here, okay, 91,82. I have enough information to work in that triangle over there. So I'm now going to move to triangle DAB. Triangle DAB is a right angle triangle, so I can use opposite, adjacent and hypotenuse. How am I going to do that? Well, I'm looking for my opposite and I know my adjacent. And so I'm going to write down that tan of 35 is my opposite over my adjacent. In other words, 91,82 multiplied by tan of 35 is equal to dA. That means that dA is equal to 91,82 times sine of 35, and it is 52,67. All right, in this case again our lengths are in meters, so we get 52,67 meters, and that's the first of the three-dimensional problems we're going to do.